Okay, we are in section 13.6, the last chapter in chapter 13, where we get to apply the law of cosines. And the law of cosines allows us to solve triangles where we're given um, side, angle, side, or side, side, side triangles. The equations for the different unknowns are shown up in the grays. If you use the a squared equals b squared plus c squared minus 2bc cosine of a, that means that you're either trying to find the length for the small a, or you're trying to find the angle to capital B, and goes on for b and c um, corresponding. So if we look at our examples, here it says we're going to try to solve triangles given side, angle, side. And to prove that it's side, angle, side, what I would like to do is let's draw a triangle. So I just draw any kind of triangle like this, and then I'll give this to be A, this is B, and this is C, which means that the opposite side here is going to be small a, the opposite side is going to be small b, and then the opposite is going to be small c. So now I'm going to just fill in the given. So this equals 22, this equals 15, and c equals 108 degrees. That makes sense. So this is, this is side, angle, side. That's where they get the side, angle, side from. So now we, excuse me, just incorporates the formula that we have up top. And in this case, we don't know what c is, so we're going to use the c squared equals a squared plus b squared minus 2ab cosine of c. So let's put in the givens. So let's say we got c squared, which we don't know, equals a squared, which is 22 squared, plus b is what, 15 squared, minus 2 times 22 times 15 times cosine of, it'll be 108. All right, so 22 squared happens to be what, 484. 15 squared is 225. And I'm going to go minus, so I'm going to take 15 times 22 times 2, which gives me 660. Multiply that by the cosine of 108. So the cosine of 108 multiplied by 660 is going to give me a negative 203.95 roughly. And then 484 plus 225 equals 709. And that's going to be c squared. So subtract a negative number, so I get plus plus, so I get 709 plus 203.95 gives me c squared equals 112.95. But that's c squared, so now I have to take the square root of that, and that's going to give me c as a distance of 30.22 roughly. So got that. Now I need to find the angles for either A or B. So let's look for A. How about? So if I know that A squared, so that's what A squared is, 484, equals B squared, which is 225, plus C squared, which is, we'll say, was it 912.95, minus 2 times b, which is 15, times it by c, which is 30.22, and we're looking for the cosine of a. We don't know what that is. So let's solve this out. So I got 484 equals 225 plus 912.95 gives me 1037.95. And then we go minus 2 times 15 times 30.22, which gives me 906.6 times it by the cosine of a. So now this is kind of like, in algebra where the cosine of a is a variable, so let's solve for the variable. So the first thing we're going to do is we're going to subtract 1137.95 to both sides, so 484 minus 1137.95 gives me negative 653.95 equals the negative 906.6 cosine of a. So I get to divide both sides by the negative 906.6, which gives me a positive 0.72 equals the cosine of a. Now, if I'm looking for the cosine of a, I can write this as the inverse cosine of 0.72. And if I punch in inverse cosine of 0.72, I get 43.95 degrees. So A is going to give me 43.95 degrees. Now to find B, I know that all the interior angles of a triangle add up to 180. So I'm going to subtract 108 and then subtract the 43.95, which then this gives me 28.05 degrees. So that's how you solve it using side angle side. If we have a triangle that is side, 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 again, I would still draw out a triangle to help you visualize it, and then still label it A, B, and C, and then opposites is A, opposite of B, and then opposite C. And then write in the givens. So here it says it's 19, 26, and then 31. So now what we're looking for is the three angles. So here's how you can solve that. So let's look for A. So here I have A squared, so it's going to be 19 squared. It's going to give me 361 equals, and then it's B squared. B squared is what? 26 squared, which gives me 766 plus, and then C squared is 31 squared, which that's 961 minus 2 times B times C, so it's 26 times 31, and then multiply that by the cosine of A. So similar to what we did in that second step in our first example. So let's solve these out. So I got 361 equals, and then 676 plus 961 gives me 1637 minus 2 times 26 times 31, which gives me 1612 cosine of A. Now again, we're just solving it like cosine of A is a variable, so let's subtract 1637 to both sides. So 361 minus 1637 gives me a negative 1276, which equals negative 612 cosine of A. So I get to divide both sides by the negative 1612, and that is roughly a positive 0.79 equals the cosine of A. Now to find the cosine of A, we just take the inverse of 0.79. So the inverse of 0.79 is roughly 37.81 degrees. So 37.81 degrees is A. And now we can do one of two things. We can do that same process for finding either B or C, or we can use the law of sines, because the law of sines says that we can use um, side-side angle in order to solve um, given unknowns. So here I have side angle, and this allows us to be able to find the angle for C. So let's give that a try. So now I have the sine of 37.81 over which the distance of A, which is 19, is going to equal the sine of C divided by the distance of C, which is 31. And you can still use the law of cosines if you wish in order to solve those values. I'm just showing you another way to do it once you've found an angle and then going from there. So if I take the sine of 37.81 and then I multiply it by 31, I get 19.00 roughly, and that's going to equal the sine of C, which is times it by 19, but that's what gives you 1. So let's say it's 1 here is the sine of C roughly, and the inverse sine of 1 is what, 90 degrees, so apparently it's roughly 90 degrees. And then if I take 180, subtract it by 37.81, and subtract it by 90, I get something roughly 52.19 degrees. Okay. Last thing we have is being able to solve what is called Heron's area formula. This is a formula that's used if we don't know what the height is and all we are given is the distances around our triangle, which we're given SSS. It's an SSS triangle. And the formula's up there. It's where you take the area equals the square root of S is the semi-perimeter, so it's the semi-perimeter multiplied the semi-perimeter minus the distance of A multiplied by the semi-perimeter minus the distance of B multiplied by the semi-perimeter minus the distance of C. So first thing we have to do is find out what S is. You can find out what S is by taking 1/2, multiplying it by 750 plus 410 plus 620. So 750 plus 410 plus 620 gives me 1780, and to divide that by 2, we're multiplying it by 1/2. So my S here is 890. So now we just get to put this into the formula. So I get area equals S, which is 890, multiplied by 890, subtracted by, let's say, A is 750, multiplied by 890, minus 410, multiplied by 890, minus 620. Okay, so let's do the math here. So I got 890 multiplied by 890 minus 750, which gives me 140. And then 890 minus 410 is 480. And then 890 minus 620 is 270. So if I go 890 multiplied by 140 multiplied by 480 multiplied by 720, I get a really large number, and my calculator tells me it's 1.614 1 times 10 to the 10th power. So a very large number. But what I want is the square root of that number. So I'm going to take the square root of 1.61 times 10 to the 10th power, and that gives me 127,075.41. And this one is square feet with the label. Okay? And that is being able to apply the law of cosines. Hope this helps. Till next time.